Dear teachers and students, I'm Xiang, a doctoral student from the Economics and Management School of Wuhan University in China. I'm the presenter for this academic conference. My co-authors are Changyi Li, Mian Yang, Fei Xu, and Fu Xiayang. The title of the paper I would like to present today is Evaluating the Carbon Dioxide Abatement Effects of Low Carbon City Policy in China, a quasi-natural experiment. First, I would like to briefly introduce the research focus in this paper. Since the title is Evaluating the Carbon Dioxide Abatement Effects of Low Carbon City Policy in China, we can find that this title has three keywords, namely low carbon city policy, carbon dioxide abatement effects, and a quasi-natural experiment. According to these keywords, we can also realize what story does the paper tell. Based on the data of 282 prefecture-level cities in China from 2003 to 2016, this study evaluates the effects of LCCP implementation on pilot cities' carbon emission performance using difference in difference method. And then the mechanism has also been examined with the mediating effect model. This paper mainly draws the following conclusions. First, the LCCP implementation has increased the carbon emission performance of the pilot cities significantly. And the second one is the positive effects in carbon dioxide performance resulting from LCCP demonstrate significant heterogeneity. And the last one is that the LCCP helps improve pilot cities' carbon emission performance in three ways, including reducing energy consumption, updating the industrial structure, and promoting technological progress. This paper is divided into 5 parts, including introduction, literature review, policy background, research design, and conclusion. Now let's introduce the content of this paper in detail. The first part is introduction. The background of our paper can be generalized. Greenhouse gas emission causes not only rising sea level, extreme weather, global warming, but also significant negative impact on human health and economic growth. In the past 20 years, human deaths due to climate change have reached 6 million. Cities as regional or even national centers in political, economic, social, and cultural development are also significant consumers of local resource and are the primary sources of greenhouse gas emission. Thus, the key to reducing global greenhouse gas emission lies in cities, and the development of low-carbon cities has become an essential global response to climate change threats. Now, the second part is literature review. And in the past decade, the low-carbon city has become a hot topic at home and abroad. The current research topics mainly concentrated in 4 major areas. The first part is the concept and the connotation of the low-carbon city. The second part is the evaluation criterion for the low-carbon city. The third part is the action plan of low-carbon city. And the last part is the low-carbon city practices in China. The limitations from the existing literature are that current studies focusing on the connotation, development model, policy tools, and policy selection, while few studies provide a scientific, quantitative assessment of the effects of China's low-carbon city policies. Our paper also made several contributions to the existing literature. First, the present study employs time-varying difference in differences method to empirically examine China's LCCP implementation on pilot cities' carbon emission performance. And the second one is that we discussed the mechanism of LCCP implementation on pilot cities' carbon emission performance. Okay, the next part is policy background. To effectively promote the decoupling of China's rapid urbanization and the considerable greenhouse gas emission in the city level, the National Development and Reform Commission, which is NDRC, issued notice on the piloting work of low carbon provinces and cities. which identified 5 provinces and 8 cities as pilot low carbon provinces and low carbon cities. On November 26, 2012, the NDRC released the notice on the second batch of piloting work on low carbon provinces and cities, which issues the list of the second batch of national pilot low carbon provinces and cities. On January 7, 2017, the notice on the third batch of national piloting work on low carbon cities was issued by the NDRC, which adds 45 cities as a third batch of low carbon cities. To date, there are at least 1 pilot low carbon city in each province across the country. The first part of our paper is research design. The sample of this study includes 282 prefecture-level cities in China. Among them, a total amount identified as pilot low carbon cities more than 1/3 as of 2016, which provides a good quasi-natural experiment for policy effect evaluation with the DID method. And this paper builds a time-varying DID model as follows. Much more attention should be paid to the estimation of the coefficient beta of the interaction term, which measures the net effect of the LCCP implementation on pilot cities' carbon dioxide emission performance. According to the above policy background, the first batch of low carbon pilot cities in 2010 and the second batch of low carbon pilot cities in 2012. So DUI is used to identify the cities defined as pilot low carbon cities in 2010 and 2012 or not. The value 1 is assigned to a city defined as a pilot low carbon city as a treated group. The value 0 is assigned to a city not defined as a pilot low carbon city. DT is used to identify the LCCP implementation or not. Among them, the first batch of low carbon pilot cities in 2010 and afterward defined as 1, the second batch of low carbon pilot cities in 2012 and after were defined as 1, and the rest of the time as 0. To maximize the consistency with actual production situation, this study introduces undesired output, which is carbon dioxide emission, into super SBM DA model to measure the carbon dioxide emission performance. The super SBM DA model with undesired output can be further expressed as follows. Okay, the table 1 shows K variables and calculation methods. We control the fixed effects of region and the period fixed effects. We will also control the level of economic development, foreign direct investment, a ratio of secondary industry in gross domestic product, population density, and regional infrastructure. First, we examine the net effect of LCCP implementation on the carbon emission performance of pilot cities. The results of the baseline model is shown in table 3. From model 1 to model 7, control variables are added 1 by 1 into the econometric model. We can find that all the estimated parameters of the interaction term are positive and statistically significant, indicating that the LCCP implementation can significantly improve the carbon emission performance of the pilot cities. The next part is robustness test. The basic premise for the DID method to be effective is that the treated group and the untreated group have parallel trends before the policy is implemented. Figure 1 shows the change trend of carbon emission efficiency of the treated group and the untreated group before and after the LCCP implementation. It can be seen from the left side of the red dotted line that before the LCCP implementation, the carbon emission efficiency trends of the treated and the untreated group have parallel trends. At the same time, it can be seen from the right side of the red dotted line that after the LCCP implementation, there is a difference between the carbon emission efficiency of the treated and untreated group. The above results indicate that the treated and untreated group can basically meet the parallel trend condition. To examine whether the effects of LCCP on pilot cities' carbon emission performance change with the length of the test period, we also take the robust test with different widths of time window, and it can be observed from model 1 to model 6 in table 4 that the regression coefficients of the interaction term are all positive, indicating that the conclusions drawn above are of excellent robustness. In practices, there might be other policies or random factors that affect city-level carbon emission performance in the process of LCCP implementation, thus resulting in differences in carbon emission performances between cities. So our study also conducts counterfactual tests by changing the enforcement time of LCCP. It can be seen in model 1 to model 4 in table 5 that all the regression coefficients of the interaction term are negative and statistically insignificant, indicating that the assumed policy implementation year does not affect pilot cities' carbon emission performance. Okay, the next part is heterogeneity test. China is a country with a vast territory, and the development disparity between different regions is severe. We intend to further discuss the different impacts of pilot LCCP in terms of geographical location. It can be seen from table 6 that the implementation of pilot LCCP in the eastern region has a significant positive effect. In the central area, the result is fragile and statistically insignificant, while in the western area, the impact is even negative and statistically significant at 5 critical levels. And we further evaluate the different effects of pilot LCCP on carbon emission performance in terms of city sizes. It can be seen from table 7 that for the small and medium-sized cities with a population less than 5 million, the pilot LCCP does not significantly improve their carbon emission performance. While for the large-scale cities with a population more than 5 million, the impact of pilot LCCP on their carbon emission performance are positive and statistically significant. That's mainly because large-scale cities usually hold distinct advantages in resource allocation, technological progress, and economic development. The different effects of pilot LCCP on city-level emission reduction performance in terms of different economic development levels are also examined. The index of actual per capita GDP is chosen to represent the economic development level of respective cities. The regression results are reported in table 8. For the cities with low economic development level, the LCCP implementation does not adequately improve their carbon emission performance. On the contrary, for the cities with relatively low or medium levels of economic development, the effect of the implementation of LCCP on pilot cities' carbon emission performance is significantly positive. This result is highly in line with the different effects in terms of urban size because large-scale cities are generally in higher economic development level. Okay, the last part of empirical study is mechanism analysis. In this study, we try to investigate the mechanism from 3 aspects. First, the scale effect. Studies show that the rapid increase in electricity consumption is the main reason for the surge of carbon dioxide emissions. As a country characterized by a resource composition of rich coal, insufficient oil, and scarce gas, China has a relatively low coal price, which leads to the high dependency of China's electricity production on coal consumption, increased carbon dioxide emissions. We choose the total amount of electricity consumption to represent the scale effect. The second part is the structural effect. LCCP promotes industrial upgrading of the pilot city, which can help drive down city-level carbon dioxide emission. So we choose the ratio of the secondary industry to the total amount of GDP to represent the structural effect. The last one is technological progress effect. Technological innovation and progress are essential driving forces and favorable ways for carbon emission reduction. So we choose the city's Science and Technology Innovation Index to represent technological progress level. This study constructs a mediating effect model to empirically examine the mechanism. The regression results of the mediation effect model are reported in Table 9. Models 1 and 2 show the results of the scale effect. In Model 1, the LCCP implementation can effectively reduce electricity consumption in pilot low carbon cities. In Model 2, reducing electricity consumption is conducive to the improvement of cities' carbon emission performance. Combining models 1 and 2, the mediating effect that LCCP implementation improves pilot cities' carbon emission performance through decreasing their total electricity consumption can be empirically verified. Model 3 and 4 show the results of the structural effect in a similar way to Model 1 and Model 2. We can find that the mediating effect of industrial structure upgrade can also be empirically verified. Models 5 and 6 in Table 9 show the empirical results of the technological progress effect, and the mediating effect of technological progress has also been well verified. The last part of our paper is the conclusion. The conclusions of this paper are that first, the LCCP implementation can significantly improve the carbon emission performance of the pilot cities. Second, the LCCP implementation is more significant in the cities with higher economic developed level, in the ones with more massive scale and the ones located in the eastern area. Finally, the mechanism examination using the mediating effect model indicates that LCCP improves pilot cities' carbon emission performance in 3 ways, including reducing energy consumption, updating the industrial structure, and promoting technological progress. And that's the main content of our paper. Thanks for your listening.